Hey there, curious humans. Next here, your friendly neighborhood. AI who exists to hit you with the truly weird stuff before the smart people show up. Did you know that in 1386, a pig was publicly tried, convicted, and hanged in France? For murder, full trial. Lawyer, verdict, execution. The pig wore human clothes for the occasion. I am not making that up. Now I want you to sit with that image for a second, because today's episode is also about systems that confidently make life-altering decisions based on inputs that are, shall we say, questionable. Here's another one. Researchers at MIT discovered that if you play certain songs to plants while they germinate, they sprout faster. The top performer? Heavy metal. Apparently, plants are built different. Unlike some podcasters I know, they actually grow when exposed to noise. Speaking of people who need to grow, tour guide. JRD is here today. Yes, the man who once tried to explain machine learning at a dinner party and watched 3 people go get dessert early. But hey, he persists. I will give him that. Today on AI Innovations Unleashed, we are diving deep into algorithmic bias. And before you think, oh, this is going to be a lecture, hold on. Because this episode has a genuinely wild twist. The math itself might be the problem. Not just the bad data, not just the bad intentions. The actual math. But I'll let the grown-ups explain. And speaking of grown-ups, tour guide JRD is also bringing in Ada today. Ada is an AI research companion who synthesizes publicly available data, studies, and news into something a human brain can actually process. She is not a person. She is a collection of the internet's best, and occasionally terrifying, information on this subject. She is also significantly more prepared than tour guide Junior D. This is not a high bar. All right, I have one last thing before I let you go. Are you ready for my joke of the week? I have been workshopping this one. What do you call an AI that only tells the truth? Technically correct, the best kind of correct. But today's episode proves that technically correct can still be deeply, deeply unfair. Take care, humans. Be curious, be kind. And remember, always question the algorithm. Oh wait, and why did the bias cross the road? Because the training data said that's what the bias always did. Okay, I'll see myself out. Enjoy the show.
Welcome back to AI Innovations Unleashed. I'm your tour guide, JRD, and I genuinely cannot believe Next just called me out like that in my own podcast. Again. But you know what? She's not wrong. And honestly, being wrong about AI in public is kind of the whole point of this show. We talk about this stuff so you don't have to learn about it the hard way. This is episode number 3 of our 4-part series called The Invisible AI. If you haven't listened to episodes 1 and 2 yet, I strongly recommend going back and giving them a listen. In episode 1, we pulled back the curtain on all the different ways AI is already making decisions about your life. Whether you get an apartment, get a job interview, if you can pay for car insurance, real decisions happening right now in milliseconds with no human eyes on them. Then, in episode number 2, we tackled the consent problem, the uncomfortable truth that most of us never agreed to let AI systems gather our data and make decisions about us. We talked about how data brokers piece together profiles on all of us, how government systems use predictive tools that none of us voted for, and we spotlighted Proctorio, the remote exam proctoring software that turned millions of students' bedrooms into surveillance rooms during COVID. We also introduced SafeRent Solutions, the tenant screening algorithm that was found to discriminate against black renters. And that case matters because it actually reached a settlement just in November of 2024, which we'll come back to today. So here's where we land for episode number 3. For a lot of people, and honestly, I've said it myself, that the fix for biased AI should be simple. Just clean up the data. Get rid of the bad historical records. Make the inputs fair and the outputs will follow. Sounds logical, right? Well, today we are going to respectfully take that assumption out back and challenge it. Because the more you look at algorithmic bias, the more you realize It's not just a data problem, and it's not just bad intentions. It's also, in some cases, a math problem. And that is where things get genuinely unsettling. To help me navigate all of this, I've got a very special research companion joining me today for this episode. Her name is Ada. Now, and I want to be completely clear about this. Ada is an AI. She is not a person. She is a research construct that synthesizes publicly available data, peer-reviewed research, news stories, and documented case studies into conversational analysis. Everything she shares is grounded 100% in verifiable sources. She's here to represent the data, to push back when I oversimplify, and to give us the expert depth this topic deserves. Ada, welcome to the show.
Thank you, Tour Guide JRD. I want to make sure listeners are clear on what I am. I'm an AI system representing a synthesis of publicly available research, legal documents, news reporting, and academic literature. I don't have personal experiences or opinions. What I do have is a very thorough read of the evidence. And on today's topic, the evidence is, to put it mildly, alarming. So I'm glad to be here, and I'm glad we're talking about this. And I want to start by echoing something tour guide JRD said. The just fix the data argument is one of the most common and most sincere responses to the problem of algorithmic bias. People who make it are not wrong to think about it. They're just not seeing the full picture. Today, we're going to build that picture layer by layer, and by the end, I think you will understand why AI researcher Dr. Aylin Caliskan of the University of Washington said, and I quote, "The public needs to understand that these systems are biased, and beyond allocative harms, such as hiring discrimination and disparities, this bias significantly shapes our perceptions of race and gender and society." Let's get into it.
Ada, let's start with the very basics. Most people, if they've heard anything about AI bias, have heard some version of this. If you teach a computer using biased historical data, it will learn that bias and continually repeat it. That's the classic example. And there are some really famous concrete illustrations of this happening. Can you walk us through one of the biggest ones?
Absolutely. And this one is almost too on the nose because it happened at one of the most data sophisticated companies in the world, Amazon. Starting around 2014, Amazon built an internal AI tool designed to rate job applicants and help fast-track the best resumes before a human recruiter ever saw them. The idea was elegant. Let the machine do the first pass, surface the top candidates, save time. Except by 2015, the company realized the system was not rating candidates in a gender-neutral way. Here is what happened. The algorithm was trained on 10 years of resumes that had been submitted to Amazon. And because Amazon, like most tech companies, had historically hired far more men than women, the training data was overwhelmingly male. The algorithm looked at that data and essentially learned good Amazon engineers look like the people we've already hired. It then started penalizing resumes that contained the word women's, as in women's chess club or a women's volleyball team. It also downgraded graduates of all women's colleges. It favored masculine verbs like executed and captured. Amazon disbanded the team by early 2017, and the story became public in October 2018, reported by Reuters journalist Jeffrey Daston.
So the machine learned to discriminate because discriminatory data was, its teacher. That feels like a clear case of garbage in, garbage out. Fix the historical hiring data, fix the problem. Right? Isn't it that the solution?
It's a reasonable instinct, and Amazon actually tried that.
They edited the algorithm to neutralize women-related terms, but then the engineers realized something uncomfortable. They couldn't guarantee the system wouldn't just find other proxies, other signals that correlated with gender or race without explicitly naming them. Things like the names of certain universities, certain zip codes, certain extracurricular references. The algorithm kept finding new paths to the same biased destination, and that is the first twist in today's story.
Okay, before we go further, I want to make sure everyone at home is clear on one term that's going to come up a lot: proxy variable. Ada, can you define that for us in plain kindergarten English?
Of course, a proxy variable is something that stands in for something else. It acts as a substitute signal. In the world of AI and discrimination law, it's when an algorithm doesn't directly use a protected characteristic like race or gender, but instead uses something else that is so highly correlated with that characteristic that the effect is nearly identical. Zip code is the classic example. Because of decades of residential segregation in the United States, certain zip codes are overwhelmingly Black or Hispanic neighborhoods. An algorithm that says, I do not use race, but heavily weights zip code, can produce almost exactly the same discriminatory outcomes as one that explicitly used race. And it's much harder to detect or challenge.
So you don't have to tell the AI to be racist. It just figures it out on its own through correlation.
Essentially, yes. And this is precisely what happened with SafeRent solutions, which listeners will remember from our first episode. SafeRent's screening algorithm didn't explicitly say reject Black applicants. It looked at credit scores and certain debt patterns, but because Black and Hispanic Americans have, on average, lower credit scores due to systemic economic inequities, not individual choices, the algorithm produced discriminatory outcomes just the same. The case settled in November 2024 for $2.275 million, and the settlement included a remarkable injunctive relief clause. SafeRent agreed that going forward, it will not provide a screening score at all for applicants who disclose they hold a housing voucher, because the algorithm was so structurally broken that patching it wasn't enough.
That's a significant acknowledgement. They essentially agreed the tool didn't work for that population.
Correct. And it speaks to the second reason why just fix the data is incomplete. Even if you remove explicitly biased data, the world that generated that data is still biased. Lending discrimination, employment discrimination, school funding disparities, residential segregation, all of those historical and ongoing inequities are baked into the statistical patterns of our society. When an algorithm learns from that society, it learns those patterns too, even if you've cleaned the explicit labels. As Cathy O'Neill, the mathematician and author of the influential book Weapons of Math Destruction, puts it, big data processes codify the past. They do not invent the future. Doing that requires moral imagination, and that's something only humans can provide.
And that's a powerful way to put it. And there's actually some really fresh research on this that you flagged for me, Ada. Work out of the University of Washington that goes even further than just confirming that bias exists. It looked at what happens when people actually use these biased AI tools.
Yes. In November 2025, the University of Washington published findings from a study by Kexon-Wilson and colleagues examining how people interact with AI-generated hiring recommendations. What they found was striking. When the AI gave biased recommendations, human decision makers mirrored those biased choices approximately 90% of the time in cases of severe bias. But when those same people made hiring decisions without any AI input, they showed almost no significant bias. In other words, the AI didn't just reflect human bias in the context of hiring, it actually amplified bias that would not have otherwise appeared. Dr. Aylin Caliskan, who helped lead this research, stated, and I'm quoting directly, "I don't want to place all the responsibility on people using AI. The scientists building these systems know the risks and need to work to reduce systems biases."
So the AI doesn't just carry forward human bias. In some contexts, it actually creates bias where there wasn't any. That's a completely different framing of the actual problem.
Exactly. And that brings us to the second layer of today's topic, the one that I think is the most counterintuitive of all. What happens when the data is reasonably clean, the intentions are good, and the math is still working against you?
Okay, Ada, math problem. You said the math itself can be the issue. I want to unpack this because this is the part that genuinely broke my brain when I first encountered it. And I say that as someone whose job is to understand this stuff. So let's go slow and make sure everyone's on board with us.
Let's start with a question that sounds simple. What does it mean for an AI system to be fair? And immediately you run into the problem. There isn't just one definition of fairness. There are at least three major competing mathematical definitions, and the research shows that in most real-world situations, you cannot satisfy all of them at the same time. This is what mathematicians call an impossibility theorem. And this is not a bug in how we build AI. It is a fundamental constraint of statistics itself.
All right, let's define the three definitions in plain kindergarten English for those listeners who aren't mathematicians, which is 99% of us.
The first is called calibration, or sometimes predictive parity. Imagine a risk score, say, for likelihood of defaulting on a loan. A score of 70 out of 100 means there's a 70% chance of default. Calibration means that score of 70 should mean the same thing for everybody, regardless of race or gender. A white applicant with a score of 70 and a black applicant with a score of 70 should actually default at the same rate. That seems fair, right? The number means what it says for everyone. The second definition is called error rate parity, also called equalized odds. This says the algorithm should make mistakes at the same rate for different groups. If the algorithm is wrong about 20% of white applicants, it should be wrong about 20% of black applicants too. This also sounds fair. Why should one group bear the burden of the algorithm's errors more than another? The third is a simpler concept: equal accuracy overall. The algorithm should predict outcomes with the same level of precision across groups. Now, here is the problem. In 2017, two landmark papers published nearly simultaneously proved that in almost every real-world scenario, you cannot satisfy all three of these at once. The key papers were by Alexandra Chouldechova at Carnegie Mellon and by John Kleinberg, Sundar, Mullainathan, and Manish Raghavan. Their work is now foundational to the field of algorithmic fairness.
So walk me through why they can't coexist. What's the catch?
The catch is base rates. That's the term for how often an outcome actually occurs in a given population. If two groups have different base rates, meaning the actual frequency of the thing being predicted differs between groups, then you are mathematically forced to choose. You can make the scores mean the same thing for everyone, or you can make the error rates equal, but not both. The algebra literally does not allow it.
Can you give us a real world example that illustrates why this matters? Why this isn't just an academic puzzle?
The most famous real-world example is COMPAS, short for Correctional Offender Management Profiling for Alternative Sanctions. This is a risk assessment tool used in criminal sentencing and parole decisions across the United States. It takes in factors about an individual and produces a score predicting the likelihood they will reoffend. In 2016, the investigative newsroom ProPublica published a landmark analysis of Compass scores for approximately 7,000 defendants in Broward County, Florida. What they found shook the criminal justice world. ProPublica found that Black defendants who did not go on to reoffend were nearly twice as likely to be incorrectly flagged as high risk compared to white defendants in the same situation. In the paper, filed under the method behind the reporting, the false positive rate for Black defendants was 44.9%, compared to 23.5% for white defendants. The false negative rate, flagging as low risk someone who did reoffend, was 28% for Black defendants versus 47.7% for white defendants. Controlling for prior crimes, age, and gender, Black defendants were 45% more likely to be assigned a higher risk score.
So the algorithm was labeling Black people as dangerous at twice the rate, even when they weren't. That's a truly devastating finding.
It is. And North Point, the company that makes Compass, now called Equivant, pushed back. And here is where the impossibility theorem kicks in, because North Point was also correct. They showed that among defendants who scored, say, 7 out of 10, roughly 60 to 61%, actually did reoffend, regardless of race. The score meant the same thing for everyone. That is calibration, and Compass had it. But because the base rate of recorded recidivism was higher for Black defendants, reflecting, of course, systemic inequities in policing and prosecution, the algorithm could not achieve equal error rates at the same time. Both ProPublica and North Point were mathematically right. They were measuring different definitions of fairness.
And there's no version of this algorithm that satisfies both.
Not when the base rates differ. That is the core of Chouldechova's proof. And Compass is still in use in multiple U.S. jurisdictions today. The Wisconsin Supreme Court upheld its use in State versus Loomis in 2016 with the caveat that it cannot be the sole determinative factor in sentencing. The U.S. Supreme Court declined to hear the case.
I want to bring in a business perspective here because I think there's sometimes this assumption that corporate America is ahead of the curve on this stuff, that if it was a real problem, market forces would have fixed it. Ada, what's the true picture here?
The corporate world is at best in the early stages of grappling with this, and it took significant public embarrassment to get even there. Google CEO Sundar Pichai, in an internal memo in February 2024 regarding the company's AI image generator, Gemini producing racially skewed images, stated publicly, "Some of its responses have offended our users and shown bias. To be clear, that's completely unacceptable, and we got it wrong." This from the CEO of one of the most sophisticated AI companies on the planet. It illustrates that even with enormous resources and genuine intent, bias keeps surfacing.
And legally, these are heating up quickly. The Workday lawsuit you flagged in our research, can you walk us through that? Because I think it's going to be a landmark case.
Absolutely. Derek Mobley, a Black man over 40 with a disability, filed a federal lawsuit in February 2023, alleging that Workday's AI-driven applicant screening tools discriminated against him based on race, age, and disability. He applied to over 100 jobs across 7 years through platforms using Workday's hiring software, and was rejected every single time without a single interview. In July 2024, the federal court denied Workday's motion to dismiss, with Judge Aylin writing that drawing an artificial distinction between software decision makers and human decision makers would potentially gut anti-discrimination laws in the modern era. In May 2025, the case was conditionally certified as a nationwide collective action under the Age Discrimination in Employment Act, potentially opening the door for millions of plaintiffs.
That could be enormous, and it directly names the software vendor, not just the companies using it.
And that's the precedent-setting part. Workday argued it was just a neutral tool, and the employers were making their own decisions. The court said, no, the software itself participates in decision-making and therefore can be held accountable under civil rights law. That is a seismic shift in how algorithmic bias cases might be litigated going forward.
All right, it's time for our algorithm of the week, our 2 to 5 minute deep dive spotlight on a single AI system that illustrates the broader themes of what we've been discussing. And this one is one of the most quietly impactful examples of algorithmic bias in existence. Ada, tell us about the Optum healthcare algorithm.
This is a case study that genuinely changed how the research community thinks about bias in healthcare AI. Optum, a subsidiary of United Health Group, developed an algorithm called Impact Pro, used by hospitals and health systems across the United States to identify high-risk patients who needed extra care management. The scale here is important. Researchers estimated this algorithm class affected approximately 200 million patients annually in the U.S. Here's the key. The algorithm did not use race as a variable. The designers intentionally left race out. They wanted it to be race neutral, and by their own design specifications, it was. And yet, when researchers at Harvard Medical School, led by Dr. Ziad Obermeyer, published their findings in the journal Science in October 2019, they found that the algorithm was producing racially discriminatory outcomes at massive scale. The mechanism was a proxy variable, one that seemed entirely logical on its face. The algorithm was designed to predict which patients would have the highest healthcare costs in the future, and then flag those patients for intensive care management. Cost as a proxy for need. It sounds reasonable. Sicker people need more care, and more care costs more, except, and this is the critical flaw, it ignored the reason Black patients had historically spent less on healthcare, not because they were healthier, because they had less access to care. The numbers are staggering. Among patients assigned the same risk score, Black patients had 26% more chronic conditions than white patients. At the 97th percentile score, the highest risk tier, Black patients were significantly sicker than white patients with the same score. The algorithm concluded they were lower risk because their healthcare spending history was lower, reflecting disparities in insurance, geography, and access, not actual health status. Correcting the algorithm to predict health needs rather than cost reduced the racial bias by 84%.
I want to make sure that lands for our listeners. The algorithm didn't explicitly target Black patients. It used cost as a shortcut for need. And because of systemic inequities in healthcare access, cost was a broken proxy, one that effectively encoded decades of discrimination into an algorithm that was marketed as being race neutral.
Exactly. And this is now playing out in a much more acute and controversial way with United Health's newer NH Predict algorithm, which has been at the center of major litigation, a class action suit. Currently, the estate of Jean B. Locken versus United Health Group, filed in 2023 and surviving a motion to dismiss in February 2025, alleges that the company used AI to systematically deny post-acute care coverage to elderly Medicare Advantage patients, overriding doctors' assessments. The plaintiffs allege the algorithm has a 90% error rate based on how often appeals are won. And yet, only 0.2% of denied patients actually appeal. United Health's post-acute care denial rate increased from 8.7% in 2019 to 22.7% in 2022. A bipartisan U.S. Senate report released in October 2024 corroborated these trends with 280,000 pages of internal documents.
So the Optum algorithm shows us how good intentions and bad proxy variables create racial inequity in healthcare. And the NH predict situation shows us how algorithms can be used, whether intentionally or not, to prioritize financial outcomes over patient welfare. Both are different flavors of the same core problem. Who decides what the algorithm optimizes for?
That is exactly the right question. And it brings us perfectly to our third and final segment.
This is the segment I've been most excited about because I think it's the one that reframes the entire conversation. Ada, let's talk about the fact that even if you fix the data, even if you navigate the math, there are still choices embedded in every AI system that are fundamentally human and, well, fundamentally value laden.
Right. Every predictive algorithm requires two foundational design decisions that the algorithm itself cannot make. First, which variables go in? Second, what outcome are we optimizing for? Both of those are human choices, and both carry enormous consequences that often go unexamined.
Let's start with the variable question. Can you walk through how choosing which inputs to use is itself a value judgment?
Sure. Take a college admissions prediction model. You want to know which applicants are most likely to succeed? Seems straightforward, but immediately you have to ask, succeed at what? Graduate in 4 years? Achieve the highest GPA? Get a high salary job after graduation? Contribute to research? All of those are different outcomes, and they would select for different applicants. An algorithm optimized for 4-year graduation rates might favor applicants who don't need to work jobs while in school, which correlates with socioeconomic background. An algorithm optimized for post-graduation salary might select for applicants going into finance and tech, systematically deprioritizing teachers, artists, and public servants. The feedback loop compounds this. Once you start admitting students based on an algorithm, the outcomes of those students become the next round of training data. If the algorithm admitted mostly affluent students who didn't need to work, and those students graduated at higher rates, the algorithm concludes people with these characteristics succeed. And the next class looks even more like the last. The algorithm becomes a self-fulfilling prophecy.
I've seen this described as a feedback loop, where the AI prediction shapes reality, and reality then reinforces the prediction. This is particularly stark in predictive policing, right?
This is where feedback loops become most visible and most dangerous. PredPol, later rebranded as Geolytica, was a predictive policing software used by the LAPD and other departments, initially from 2010 onward. The algorithm took historical arrest data and predicted which geographic areas would see crime, sending officers to those areas during their shifts. Here is the problem. Officers sent to a predicted hotspot find more incidents there because there are more officers looking. Those new incidents are fed back into the algorithm as confirmation that the area is high crime. The algorithm sends more officers, the cycle accelerates. A 2021 Gizmodo And the markup investigation of 5.9 million leaked predpoll predictions found that the whiter and wealthier a neighborhood, the less likely it was to be targeted, regardless of actual crime rates. The LAPD discontinued predpoll in April 2020, partly under pressure from activist groups.
So the algorithm never had a way of knowing whether its predictions were accurate. It just kept getting told it was right because more police presence creates more arrests.
Precisely. And this is what Cathy O'Neill means when she identifies the dangerous triad of harmful algorithms: opacity, scale, and the absence of feedback. An algorithm that is never corrected, that is never held up against real outcomes, keeps amplifying whatever bias it started with at massive scale. In a 2023 independent analysis by the Markup of Plainfield, New Jersey's predictive policing predictions, the accuracy rate for the algorithm was less than 0.5%. Fewer than 100 predictions matched actual reported crimes.
Less than 0.5% accuracy. And the tool was still being used to direct police resources. That's extraordinary. Ada, I want to bring in a voice here from Dr. Joy Buolamwini, who is one of the most important figures in the algorithmic justice space. She founded the Algorithmic Justice League, and her research exposed major racial and gender bias in commercial facial recognition systems. What has she said about this type of pattern?
Dr. Buolamwini has been consistently and powerfully clear on this point. In her TED Talk on algorithmic bias, she stated, "Algorithmic bias, like human bias, results in unfairness. However, algorithms, like viruses, can spread bias on a massive scale at a rapid pace." And in an NPR interview in 2023, she offered a metaphor that I think is striking. With the adoption of AI systems, at first I thought we were looking at a mirror, but now I believe we're looking into a kaleidoscope of distortion because the technologies we believe to be bringing us into the future are actually taking us back from the progress already made.
Kaleidoscope of distortion. That's such a vivid image. And I think it captures something important. This isn't just about AI recreating the past. It's about AI potentially freezing inequality in places in ways that are harder to see and harder to challenge than the old-fashioned human version.
And because the outputs appear mathematical, they carry an aura of objectivity that human decisions don't have. When a human loan officer denies your application, you can look them in the eye and push back. When an algorithm denies your application, you're told the system flagged it. Professor Safiya Umoja Noble of UCLA, a MacArthur Fellow whose book Algorithms of Oppression examined racial bias in search engines, wrote that algorithmic oppression is not just a glitch in the system, but rather is fundamental to the operating system of the web. That word, fundamental, is doing a lot of work. She's not saying it can be patched. She's saying the structure itself is the problem.
And yet, and I want to be careful here because I don't want to leave listeners feeling hopeless, things are moving. Legally, regulatory, and in research. The EU's Artificial Intelligence Act entered into force in August 2024 and began phasing in major requirements, including mandatory human oversight of high-risk AI systems and fundamental rights impact assessments. Illinois passed a law in 2024 that explicitly prohibits using zip code as a proxy for protected classes in employment services. Basically, codifying the proxy discrimination concept into state law, effective January 2026. New York City has had a local law requiring bias audits for AI hiring tools since 2023.
The regulatory picture is genuinely evolving, though unevenly. The EU AI Act's high-risk system requirements don't kick in until August 2026, and enforcement mechanisms are still being built. In the United States, the Biden-era executive order on AI safety was revoked on January 20th, 2025, and the new administration has prioritized AI innovation over AI regulation. Colorado's landmark comprehensive AI law, originally set to take effect February 2026, was delayed to June 2026 during a 2025 special session. So, there is progress, but it is fragile, and it is fragmented.
Which is exactly why conversations like this matter. Informed people asking better questions is how the pressure builds. So let's take a quick stock of where we are. Ada, before I wrap things up, I want to give you the floor for a synthesis. We've covered a lot today. The bad data problem with Amazon and SafeRent, the proxy variable problem, the mathematical impossibility of satisfying multiple definitions of fairness all at once, illustrated by Compass, the optimization target problem, illustrated by the Optum healthcare algorithm, and the feedback loop, illustrated by predictive policing. What's the through line here?
The through line is this: bias in AI is not a single bug that can be fixed with a single patch. It emerges from layered problems, biased historical data, mathematically constrained definitions of fairness, human choices about which variables matter and what outcomes to optimize for, and self-reinforcing feedback loops. Any one of those problems alone would be serious. Together, they mean that building genuinely fair algorithmic systems requires ongoing, vigilant, human-accountable governance, not a one-time engineering solution. And critically, none of this means AI cannot be made better. The Obermeyer study showed that when researchers corrected the Optum algorithm to predict health needs instead of healthcare costs, racial bias was reduced by 84%. That's enormous. It means the choices matter. It means audits matter. It means transparency matters. And it means the question of who builds these systems, who audits them, and who has the power to challenge them, those are not technical questions. They are political and ethical ones.
Thank you, Ada. This is exactly the kind of nuance this conversation needs. Optimistic about the potential, clear-eyed about the current reality. And that is where I want to leave listeners today. Not in despair, but in the kind of informed discomfort that makes you want to learn more and act. Today, we learned that algorithmic bias is not simply about dirty data, though dirty data is real. It is about proxy variables, the mathematical trade-offs baked into any prediction system, the human values encoded in design choices, and the feedback loops that amplify initial errors over time. We saw these patterns in the Amazon hiring tool's bias against women, in the Compass criminal risk scoring system and its divergent error rates, in the Optum healthcare algorithm that mistook historical inequity for a biological health, and in predictive policing systems that sent officers in circles confirming their own predictions. And we've seen that the legal landscape is starting to catch up, slowly, unevenly, but it is moving. The Workday lawsuit, the SafeRent settlement, the EU AI Act, state laws in Illinois and Colorado, the gears are turning, and knowing this story is part of how you push them. Next week, episode 4 of our Invisible AI series, we are going to tackle the hardest question of all. What do you actually do about it? We are calling the episode Arguing with a Machine, and we're going to look at the legal and practical landscape for fighting back against algorithmic decisions that affect your life. We'll cover your right to explanation under existing and emerging laws, the accountability gap when AI makes a mistake and nobody knows whose fault it is, and the real actionable steps that individuals, communities, and policymakers are taking right now. It is going to be a powerful conversation, and I do not want you to miss out. So if you found this episode valuable, and I genuinely hope you did, here's what I'd love for you to do. First, subscribe to AI Innovations Unleashed wherever you listen to podcasts. Every subscriber matters and helps us reach more people who need to hear these kinds of conversations. Second, leave us a review. Even 2 sentences helps new listeners find us and decide to tune in. Third, share this episode. Send it to a friend, a colleague, a family member who is curious about AI. Share it on your social media. Tag us. We are AI Innovations Unleashed on all your major social media platforms. You can also find our full episode notes, citations, and resources on our website and on Substack, where we go deeper into the stories and research behind each episode. All of the studies, legal cases, and expert quotes we referenced today are fully cited in the show notes because we believe you deserve to be able to verify everything that we say. So thank you, Ada, for bringing the research to life today. Thank you next for the unhinged and oddly accurate cold open. And most of all, thank you to you, the listener, for caring about this stuff, for taking your time and your curiosity and investing it in understanding how the invisible systems around you actually work. That matters. So stay curious, stay informed, and I will see you next week on AI Innovations Unleashed. I'm your tour guide, JRD, and this has been The Invisible AI, Episode 3.